Hello, everyone, and welcome to our webinar for today. My name is Gino Sigismondi. I'm the Associate Director of Technical Support here at Shure, and joining me today is Troy Jensen from our Market Development team. We are going to be talking about voice lift systems for meetings and conferences today, taking a look at some of the features and benefits and technical issues that you might need to keep in mind when you are doing such a system. It's becoming a topic that's been coming up more and more recently, and figured like this was as good a time as any to try and get a little more education out there about it. Before we get into the main presentation here, just a few items to keep in mind. First of all, this webinar is being recorded and will be archived later on at shure.com/training. Usually takes us about a week or so to get everything sorted out and get that posted. So if you are looking to revisit this topic again or share it with some of your associates who might not have been able to join us today, again, you can look for that at shure.com/training. Second thing to know about the webinar is that we will answer questions at the end of the presentation. So if you would like to ask a question, you can enter it at any time in the questions pane. So in the GoToWebinar control panel, there's a little section for entering questions there. If you can't see the control panel, just look for that orange arrow usually on the upper right hand side of your screen there. You can click that arrow and it will expand that control panel out so that you can type your question in there. So again, feel free to ask questions at any time that you would like, but we will answer them again at the end, and we should be able to leave plenty of time for that. So let's get into it here. Some objectives, just to kind of lay out what we're going to try and get through here, because it's worth noting that we're not going to be able to teach you every single thing that you would need to know to successfully design a voice lift system. So we'll kind of lay out what you should expect to be able to learn through our about 45 minutes we have here. Number one, determine if your facility is a reasonable candidate for a voice lift system. The important point there is that not all rooms, all facilities are necessarily going to allow for a voice lift system to actually function in the way that you might expect. Learn about selecting the right microphone system that will allow you to obtain your desired results. Not all microphones are created equal. Some are better suited for some applications than others, and we'll kind of discuss some of the ins and outs of choosing a microphone for voice lift. Calculate the amount of gain you can expect to achieve as part of your system design. Believe it or not, you can actually use math to go in and come up with a pretty good prediction as to whether or not your voice lift system will actually function and give you the benefit that you're after. And finally, tied in with that, determine if the benefit justifies the cost of implementation. A voice lift system can be quite expensive, especially as compared to just more traditional sound system or sound reinforcement system. So it's worth having some discussions with the client about, this is what you can expect and this is what it's going to cost. And, let's make an educated decision here. A lot of what we're going to talk about is, today is like how to make an educated decision about voice lift in general. So to start off with, I think we should define what is voice lift. What do we mean by that? In the simplest way we could possibly come up with to put it, voice lift is an attempt to provide just enough sound reinforcement into the room so that the farthest listener from the sound source can hear just as well as the closest listener. This is worth pointing out because it's different than a traditional sound reinforcement, or what people sometimes call a PA system, where often you're trying to amplify a voice to make it louder to a point where it's unnatural, right? It's louder than you would expect at normal conversation level speech. You're actually, by reinforcing, you're actually exceeding the natural level. In a voice lift system, in a particularly well-designed voice lift system, the furthest listener may not even realize that there's actually a sound system at work or in play until you were to turn it off, and then all of a sudden they can't hear that main talker or the main sound source any well. So it's a much more subtle type of reinforcement than you typically would have with a system. And that's why sometimes that cost-benefit analysis comes into play, because someone may feel like, I don't understand what I just paid for here. I don't even notice anything until you turn it off, and then they would realize what the benefit of the system is there. So again, for any unaided listener, for any talker or any listener who can hear the talker just fine unamplified, you want the person at the far end of the room to be able to hear just as well. That's your goal with a voice lift system. So what you're doing here really is you're compensating for the inverse square law. And when I turn it over to Troy for the math part in a little bit, you'll hear more about what that actually means. Oftentimes, the voice lift system is deployed in conjunction with an AV conferencing system. So you might have a room where you're already set up to conference with other locations. So the microphones have maybe just been used to bring your voice to another location. But if it's a large enough room, there may also be a requirement for a voice lift so that other participants in the same room can hear just as well as, again, the close listeners are. A digital signal processor of some sort is required for the complex signal routing and system adjustments that are needed for a successful voice lift system. In the past, of course, this had been done with analog components. It's a little bit more. I hate to use the word simplified, but I guess it's a little simpler than trying to do it with analog components. So you're going to have some sort of digital signal processor in play here for this to work successfully, because it is more complex than a traditional speech reinforcement system where you might, if you've got, one talking head at the front of the room giving a presentation, you could have a couple of speakers on sticks and a handheld mic and you're probably in good shape. But to make the voice lift work in the way we want it to, where there's often multiple participants, large rooms, challenging acoustics, it is going to be a much more complex system. Hence my earlier point that we may not be able to teach you everything you need to know today, but at least we can hopefully set you down the right path. One of the first things that you really need to think about is determining if your facility can benefit from voice lift. So there's some questions that you need to ask before heading down this path. One of which might be, is this an existing facility with an already installed sound system? As you're going to learn in a little bit, how the microphone signals get routed within the room and to which loudspeakers they get routed to, as well as the relative position between those devices, largely determines whether or not a voice lift system is going to be successful. And if you're already kind of locked into certain elements because the system's already installed, that could affect the overall results or the success of the system. Another really important question is, does the room even need reinforcement? Sometimes voice lift is thought of as something that should just be added on just because we want everybody to be louder. But you really need to sit and analyze the room and have a meeting or a conversation in there and really determine if voice lift is actually required. Because chances are, if it's not actually needed in the room, trying to make it work in the room is going to be even that much more challenging. So it's an important question to ask. Of course, the types of microphones that you're using will play into this when we start talking about the math and how those relationships matter here. The type of microphone and where it's placed will have a large impact on that. As far as what is acceptable, if there's architects in play, that it might impact whether or not you can actually even have a microphone on the table. Maybe you have to find an alternative solution to mics on the table, which means the microphones are further from the talker, which complicates things in ways that we'll see here. So that's an important consideration. And of course, the environmental conditions, right? Acoustics of the room, any background noise that is present in the room. We'll talk a little about more in this detail too, but the room itself, the physical room, does have some bearing, again, on the success or lack thereof of a voice lift system. The final point here, italicized, is that the introduction of voice lift into an existing conference system will affect the performance of an acoustic echo canceller. So if this is being implemented in a room where you've already been doing AV conferencing of some sort, the presence of a voice lift system will impact how that acoustic echo canceller works. So you'll likely also need to revisit that system and make some further adjustments there to compensate for the fact that now we are doing voice lift as well. And with that, I'm going to turn things over to Troy to kind of get into some more of the nitty-gritty here.
Thank you, Gino. And we'll do a little bit of math here. The first thing that we're going to be looking at is the inverse square law. And the rule of thumb for this is you have a 6 dB level drop for every time you double the distance from the source. The one thing with the inverse square law and some of the other equations we're going to be looking at here is that the assumption is that both loudspeakers and microphones are omnidirectional in nature. We are well aware that there are no such pure omnidirectional components in the systems that we install, and that will affect somewhat what your overall results are. But for the purposes of calculating things, we're assuming fully omnidirectional source and a fully omnidirectional receiver. Now, with respect to the inverse square law, there is an equation for that, particularly with distance. 20 log R1 divided by R2, where R1 is your first distance and R2 would be your second. And if we look at the rules of thumb for inverse square law, if we have calculated or measured a value at a known distance and we cut that distance in half, we're going to get a 6 dB increase. If we increase that distance by half, we're going to lose 6 dB. Now, if we don't double it or we don't cut it in half, the 20 log R1 over R2 will give you values depending upon where your first distance is either calculated or measured with SPL, and then the second distance. And you'll either get a positive value or a negative value when you run that equation. So that works in both directions. And that'll come in again when we start talking about or calculating what we're talking about now, which is potential acoustic gain and needed acoustic gain. And this is a method that has been around since the late 60s, in which you can calculate the gain of a sound reinforcement system under design. And there's the big, long, scary equation that we have. And the front part of that equation is the needed acoustic gain, and the back half of that is the potential acoustic gain. And the variables in this equation are the number of open microphones. So if you have 1, 2, or 3 microphones open as part of the system, you're going to want to have that value or the maximum of that value. The feedback stability margin is essentially your headroom. And for the most part in voice lift, we're looking for about at least a 6 dB feedback stability margin for safety's sake. The equivalent acoustic distance is a distance between the source or the talker and an unaided listener, so that speech is still heard unamplified and is a reasonable level, and you're going to need to know what that distance is at that particular level. D sub 0 is the distance between the talker and the farthest listener. D sub 1 is the distance between the closest loudspeaker to the microphone. D sub 2 is the distance between the loudspeaker closest to the farthest listener. And then finally, D sub S is the distance between the sound source, the talker, and the microphone. Probably the two most important components here are the D sub S and the D sub 1 value. It being that we're trying to get the microphone as close to the talker as possible and as far away from the active loudspeaker as possible. And if you do that, you can usually receive some appreciable benefit with respect to gain before feedback in the system that you're designing. Now, here we have a diagram of a more traditional conference space, and the good news is that there are spreadsheets and websites available that will do the calculation for you. So you don't have to worry about that big, scary calculation that you saw on the previous page. And Shure is among one of the people that have a calculator on our website, and you can certainly use that to your advantage. Gino's going to take you through some of the particulars on how to plug values into the calculator.
Yeah, let's take a look at that here. So let me get over to Safari here. There we go. Okay. So what you're seeing here is the potential acoustic gain calculator that's available on Shure's website. Again, there are others, but this is one that we have. You can find it by going to Shure.com and just typing PAG in the search bar. It should be the very first thing that that comes up here. So some things to note about it. You can choose your units, feet or meters. That's kind of a convenience. And you can choose your microphone type here at the top. And this is really more for visualization purposes than anything else. You'll see that you've got 3 choices: gooseneck, boundary, and hanging. And again, so if I change it to boundary, you see the gooseneck mic goes away. Now there's a boundary microphone. If I go hanging, table mic goes away and there's a little microphone hanging up there. But it's important to note that D sub S, the distance between the microphone and the sound source, or D sub 1, the distance between the microphone and the loudspeaker, does not actually change here. It's still reliant on you to actually put those accurate values in here. So it's really just, again, to help you sort of visualize what you're dealing with here. The first kind of value that you have to put in here is number of open microphones, because the more microphones that you have turned on and open through the sound system, the more likely it is that you might get to the point where you're going to reach feedback occurring. The little question under here says, are you using an auto mixer, yes or no? You'll notice if I click it to yes, the box grays out and it changes to 1. And that's because if you're using an automatic mixer with a NOMA circuit, number of open microphones attenuator, the mixer is sort of keeping the overall output of the mixer such that the gain is equivalent to if only one microphone was open. So every time you double the number of open mics, it reduces the mixer output by 3 dB, so that the mixer helps you kind of stay below that feedback stability margin. So that's why that changes there. So we'll leave that now. We're saying we're using an auto mixer. You probably should be in a voice reinforcement system or a voice lift system. So then we just go add the distance for like talker to furthest listener, and you'll notice that here, when I click on that box, the numbers of interest or the people of interest kind of turn blue so that we know what we're dealing with. And you can see the talker and the farthest listener, and we'll say that they're about 12 feet away here. And then the microphone to loudspeaker distance, again, that's the closest loudspeaker. And that's assuming that this microphone signal is coming out of this loudspeaker, which, as you'll see in a little bit, you maybe don't want to do in a voice lift system, but for our purposes, there it is. And we'll say that's about 6 feet. And then farthest listener to their closest loudspeaker, so not the loudspeaker that the microphone is closest to, but the loudspeaker that the listener is closest to. And they're about 6 feet apart. Talker to nearest listener, this is actually in the previous slide we referred to as the equivalent acoustic distance. Here it's called D sub 3, it's the same thing. But talker to nearest listener, we'll say they're 3 feet apart. And then, of course, most importantly, the talker to microphone distance. In this case, they're about 3 feet apart. So now we've got some results since we put all the numbers in here, and you can see that our potential acoustic gain is 12. Our needed acoustic gain is 18. So we are 6 dB shy of where we actually need to be. Really more than that if you include a feedback stability margin. So this system will suffer from feedback, right? The component values are not distances are not in a place that's actually going to work for us. There are a couple of different ways we can play with the numbers to try and get a little bit closer. Of course, moving the microphone further away from the loudspeaker is always a good way to go. So if we were able to relocate our loudspeaker or do something else to increase that distance to, let's say, 10 feet. Oop, that didn't work. Let's try this again. 10 feet. There we go. Well, yeah, we're still not quite there. 16.5 for a potential acoustic gain. We can move the microphone closer to the talker's mouth. Oh, look at that. Wow, that made a big difference, didn't it? We went from 3 feet away to 1 feet away. Now we're in the green. Now this system is going to operate well without feedback, with plenty of buffer here. And that's kind of an important point. Often the cheapest and easiest way to get more gain out of your sound system is to get the microphone closer to the talker. Let's back it off to 2 feet and see what happens. Well, not 21 feet. That's certainly going to be bad. 2 feet. So 2 feet, we're in, now it's yellow-ish. We haven't really seen this before. We saw green, which is good to go. We saw red, which is probably going to have feedback. Yellow says the system may suffer from feedback, and this is that 6 dB feedback stability margin that Troy referenced earlier. When you see yellow in our calculator, that means that, our PAG is greater than our NAG. That's good, but only by 2 dB. So you're kind of be skating on the edge here of what actually might work. So you might want to change some things around to get in a little bit better shape. Just to kind of drive another point home here, again, I'll change this to a hanging microphone because the architect has determined that there will not be microphones on the table, so we're going to hang a microphone instead. Now, again, notice by me changing this, nothing changed here, but to be accurate, I actually do need to change this because now the microphone is further from the talker's mouth. Probably could be, not 25 feet away, but let's say 5 feet away. Well, see, now we're into feedback. And actually, what else has changed here? Well, the microphone is actually much closer to the loudspeaker now. That microphone might only be 3 feet from the loudspeaker. Oh, well, that's really bad. Potential acoustic gain of 1.6 when we need 18. We're not anywhere close to where we need to be. So we would definitely need to consider things. But this tool, again, it's really a useful thing to do to kind of start doing some pre-visualization and seeing if what we expect to have happen here is actually going to happen or not. Okay, I'm going to turn it back over to Troy for some loudspeaker considerations here.
Yeah, and so one of the ways that you have the ability to increase D1 is to create loudspeaker zones, and I would say that the voice lift a voice lift system requires that a loudspeaker output in any given zone is devoid of a microphone that are active in that particular zone. And this is a method by which we can increase that D1 in a voice lift system. This is often referred to as mix minus. In the past, voice lift systems have been referred to as mix minus systems. This is a little bit of a throwback to ye old analog days. There were back with analog systems, we would play with polarity and or phase and gain to try to subtract the local microphone out of the mix in order to achieve a higher level of gain before feedback. These days, we're looking pretty much at DSP product to achieve that for us via a mix matrix, for example. And we're looking at a separate output for each loudspeaker zone. So, as we mentioned, voice lift requires that the sound output in any given zone is devoid of any microphones that are active. And here's a graph showing that we are now not routing a microphone that is close to the person who's talking through the closest loudspeaker, but only routing it through a further loudspeaker. Again, in an attempt to increase that D1 distance in order for us to achieve some reasonable gain before feedback. So, in the simplest of voice lift systems, a minimum of 2 loudspeaker zones are required. There is no way with any microphone that you can get your hands on that you're going to create a voice lift system in a single zone loudspeaker system. It's just not going to happen. We've had people try, but it is not going to work. So, in its simplest form, you're looking at a 2 zone system when you're looking at voice lift systems. Ideally, you would increase the number of zones, which are going to help you achieve maximum gain before feedback from the system. And again, what you can do with this now is you can do what I like to refer to as a little bit of gain shading, whereby adjacent zones may be able to have a little bit of an active mic from, let's say, zone 1, and you might be able to introduce a little bit of that microphone into zones 2 and 4, but you would be able to increase the gain of that microphone in zone 1 in zone 3, let's say, because those speakers were farthest away. Again, that D1 distance that you're looking to increase. The other thing you can do is look at some of the newer Dante PoE loudspeakers. This makes the ability of increasing your zones uh, quite easy because every loudspeaker that has a direct home run back to the switch could essentially be its own zone. And it gives you the ability to change that in the field if you needed to do that for whatever reason. And it's relatively easy to configure. Typically, we're looking at ceiling loudspeakers. You could do this, I suppose, with a wall-mounted speaker if you wanted to do that. That might add some additional complication, but distances will still be an issue that you need to take a look at. If we're looking at a traditional 70-volt system, you're going to need an amplification channel for every run of loudspeakers. Each zone will need to have an amplification channel separate from the others. And again, as I mentioned previously, Dante PoE loudspeakers make the creation zones a much easier process than the traditional 70-volt systems, and also gives you the ability to reconfigure it in the field if you need to make any additional adjustments. As for microphones, we're going to look at some real-world conditions here. And in this particular case, we have a client who does not mind, thankfully, to put microphones on the table. And we can look at some real world values here where they may be a couple of feet away from the microphone, whether it be a boundary or a gooseneck type microphone. And we plug some of our values in here as far as our distances from the microphone. You'll notice here that I have a question mark on the number of open microphones. And what I often do is I increase, I'll in this particular website or PegNet calculator, I will say no to using an auto mixer, and I'll add a few open microphones to give myself an additional headroom or additional stability margin, if you will. I can always lower that, and I can always turn auto mixer on yes, which will reduce that value to 1. But if I want to be a little bit more conservative, I can increase the number of open microphones to ensure that in addition to that feedback stability margin, I've got a pretty good operating system and I can get enough gain. And after plugging all of the values in, we can see here that, well, I do get an appreciable amount of gain from this system, given the geometry of this space and the distances within this room. But the question always comes up, do the microphones have to be on the table? And sure enough, some people will make an attempt to put the microphone on the ceiling, and hopefully they don't do so without doing their calculations first. Because here we have another scenario now where we have put the microphones flush into the ceiling and space them between loudspeakers within the room. In this particular case, I have 3 different loudspeaker zones. I have moved the microphone now to the ceiling, which has increased the D1, I'm sorry, increased the D sub S distance, and actually decreased the D sub 1 distance, moving that microphone a little bit closer to an active loudspeaker zone, which is, in this case is zone 2. And you can see here that I fall quite a bit short of any appreciable gain within the system. Now you can say, well, perhaps we don't want to feed that microphone into zone 2, and you would be correct. I would say that any person who is within, well, let's say 12 feet of the person who's talking probably doesn't need any reinforcement. So that first position, that gentleman who's sitting next to the woman at the end of the table, probably doesn't need any voice lift. The second person is maybe, yeah, about 12 feet away, so they're right on the edge, if you will, of perhaps needing voice lift. Now, the person who is 18 feet away is probably benefit somewhat from doing some voice lift. So in this case, now I'm going to not route that closest microphone to the person who's doing the talking, and I'm only going to route it through zone 3. And even still, you can see that we're somewhat in the orange area. We're not within that feedback stability margin. You could certainly cut down on the number of open microphones if you wanted to do that. But this is still showing me that I'm still on the hairy edge of maybe not having a stable system with respect to gain before feedback. Now, this is probably a good point to illustrate also that if you think about these systems in terms of number of inputs and the number of zones, meaning the number of active microphones and the number of zones, if you take the number of the number of microphones and the number of zones that you have, and you times them in a very simple illustration like this, I have 4 microphones and I have 3 zones. This is going to give me 12 cross points on a matrix, right? So if I'm going to do this Pagnag equation, I want to do it for the worst case scenario. And the worst case scenario is going to be where the microphone is furthest from the talker, so that my D sub S is the greatest distance, and my D sub 1 is the shortest distance. That mic is furthest away from the talker and closest to an active loudspeaker. If I get a green light on that single calculation, that probably gives me a good indication that I'm going to be successful with all of the other positions. But if you think about this system, 4 times 3 zones gives me 12 cross points. Ideally, before I go into the field and I try to make adjustments, I would probably want to run my PAGNAG for each one of those cross points so that I had a good understanding of what my actual gain before feedback would be for each of those scenarios. So it's always a good idea before you get into the field and start trying to increase gain and create a feedback machine to have an understanding of just about how much gain you're going to be able to get, and then slowly increase your gain to those values that hopefully you've calculated. So that's key. And as Gino mentioned, then the next thing is, well, we look at pendant mount microphones, for example, and certainly dropping the microphone down can help. But as we saw in the inverse square law, you have to have that distance to get an increase of 6 dB. And in many of these systems, I don't see the microphone drop down more than 2, 3, 4, maybe 6 inches at most from the ceiling, which is not going to get you an appreciable amount of gain. Certainly won't take you from a stable system or I should say an unstable system to a stable system. You would need to cut that in half, and in most cases, they're not going to allow you to drop the microphone 4 feet from the ceiling and leave it dangling in midair. It's just not going to be practical or aesthetically acceptable on behalf of the client or the architect that you might be working with. So some issues to keep in mind there. And of course, people have come to us with our new ceiling array microphone and asked if they can use it for voice lift. And the answer is yes. The 910 actually provides more gain before feedback than traditional mics, but it introduces another consideration in that you have the ability to move lobes around. Now, you don't have that with a static microphone, so you need to take great care when you're aiming the lobes, because ideally what you're not looking to do is aim a lobe into a zone in which it's been routed. If you do that, you can almost ensure yourself that you're going to have feedback. And you can see that from some of the calculations here in the spreadsheet that we actually have, I would say, at least a 6 dB increase over traditional cardioid and omni microphones when we're using the MXA 910 to improve the gain before feedback. And how do we get that? Well, we get that because of how directional each of the lobes are. On the far left over here, we have an example of a supercardioid polar pattern, and it obviously is more broad than any of the lobes that we've measured, whether it be in the wide, medium, or narrow setting on the 910. And in particular, for voice lift, you would probably be most interested in the medium and the narrow settings to get maximum gain before feedback. And you can see how much more narrow those polar responses are over a hardware-based microphone like a supercardioid. And that's where the magic and the additional gain is coming in. Again, because those calculations are based on omnidirectional microphones and loudspeakers, as soon as you go to a more directional microphone, you're going to pick up additional gain before feedback. And here is a graphic showing how to adjust those lobes. I have a blue lobe from the Zone 1 MXA 910, which is routed to the Zone 2 loudspeaker and not routed to the loudspeaker in which the lobe is currently aimed. And then from the Zone 2 MXA 910, I have a lobe from that zone only routed to the Zone 1 loudspeaker. So uh, the blue lobe is routed to Zone 2, and that brown lobe is routed to Zone 1.
If I could just interject something there for a second, Troy, because I think it's worth pointing out too that part of our interest in even discussing this topic was the introduction of the MXA 910, which was developed, when we were working on it here at Shure, was thought of as a microphone for AV conferencing, right? It didn't matter as much that the microphone was in the ceiling in terms of feedback, because we didn't think it would be used for reinforcement. It was purely thought of as like, yeah, you're going to use this for your AV conferencing system to, get the mics off the table, but still allow you to have a conference with another location. And then, Troy, I think you were one of the first people to start getting the calls here from customers saying, well, I put one of these in the ceiling for my voice lift system, and now I'm getting feedback. So
And that was really my earlier reference to there is no microphone on the planet that will allow you to take a single zone system and create a voice lift system out of it. I did get a couple of calls from several individuals who thought that the MXA 910 could perform magic. And my first question to them, well, was the system designed for voice lift to begin with? And there was a long silence. And the answer was no. It was a single zone 70-volt system, which they just tried to throw an MXA 910 in the ceiling. And of course, that wasn't going to work because the loudspeaker system wasn't zoned. So that is key. And a couple of other considerations. EQ is definitely your friend. I would not rely on equalization to take an unstable system and make it stable. The EQ there is to provide additional gain and simply to make the system sound better. The good news is that any EQ that you use as part of your conferencing system to improve intelligibility on the far end usually provides an improvement in gain before feedback. So low cut filters or high pass filters and notch filtering, all of those things are going to be key. But a particular note to the notch filtering, I mean, you can do too much EQing, right? To a point where if I'm just notching a lot of frequencies out, all I'm really doing is turning the gain down. So notch filtering of specific frequencies is good and is useful, but it should not be overused. And hopefully, if you've designed a system around some of the guidelines that we've already provided, you shouldn't have to use too much EQ to improve gain before feedback. You should be in relatively good shape, and hopefully, then you're just using some EQ to make it sound better or flatten the response out a little bit. A word of caution on dynamic feedback suppression. It's not recommended when you're trying to deploy voice lift along with a conference system that has acoustic echo cancellation in it. So either teleconferencing or video conferencing. The dynamic part of the feedback suppression is probably going to mess with your acoustic echo cancellation a little bit, and I would try to avoid that. You certainly could use it to establish what frequencies you want to notch out of the system, and then turn the dynamic part of that off so that it's not running while you're involved with a conference. Here's an example of two different paths with respect to equalization. And the one path is directly to the codec, and you can see we have EQ, the acoustic echo cancellation, and the noise reduction as part of that signal chain directly feeding the codec. And then we have a split off from the mic channels that have separate EQ, specifically for the voice lift, the reinforcement within the room. And this is a good way to design your DSP and improve the overall EQ of the system, and without really affecting what you're sending out to the far end. Some environmental considerations. The size of the room is certainly an issue. As we get into larger spaces, ceiling heights get higher, and will probably affect your ability. I will also say that in some of the examples that we showed here, certainly somebody who's sitting within 12 feet, it's a little too close to try to employ voice lift. So unless they are a reasonable distance away, voice lift is probably not the right thing to try to attempt to do in the room. And so you're going to have a range, right? There's going to be rooms that are probably too small, and there are probably going to be rooms that are too large in terms of trying to figure out whether or not it's a good candidate for voice lift. Ambient noise level in a room, or NC levels within a space, noise criteria. When you start to get rooms that have a very high noise level, you're going to need more gain out of the system to compensate for the noise level in the space. And so that's key. Um, the I've been in a couple rooms where the NC level is relatively high, where people were trying to achieve voice lift, and there was just not enough gain out of the system to overcome the noise level in the room. So making a measurement within the space as far as your NC level is concerned, your noise level in the room, might be good practice as well as part of your calculations. Interior acoustics. If the room is performing poor acoustically and it's a difficult room to have a video conference or an audio conference in, voice lift is not going to improve the situation. So, a poor room acoustically is usually going to result in a poor room for voice lift. Again, I see a lot of rooms being designed where 3 of the 4 walls are all glass. These are not great rooms acoustically. If you can have influence on acoustical treatment, interior finish in the space, absorptive materials, making the room more acoustically inert, carpet, acoustical panels, ceiling tile, always should be used to improve the acoustics within the space. So, some key concepts here. Determine the suitability of the room for voice lift. We talked a little bit about size of the space. We talked about acoustics within the space and what will work. Client expectations. This is one of the biggest things, I think. When we talk about voice lift systems as a whole, uh, people are thinking rock and roll concert, and voice lift is not that. So when we start talking 3, 4, 5, 6 dB, it's important for you and or your client to fully understand what 3, 4, 5, or 6 dB is and how much money is going to be spent to achieve that additional increase in gain. And is it going to be enough to make yourself or the client happy? So those are important things to work out ahead of time before you go through the expense of implementing voice lift. Calculate PAGNAG. There is no way around running a calculation to determine a go no go situation. And again, that is a relatively long D1 with a short DS. So closer to the microphone, better. Further away from the next active loudspeaker is key. And certainly, once you're moving forward towards commissioning, doing a calculation at each of those cross points so that you have a good understanding when you walk into the room what kind of gain you're going to be achieving. Loudspeaker zones are key. You need to do that either with separate 70-volt systems or, as I mentioned previously, Dante-enabled loudspeakers of PoE makes it a little bit easier. Make sure you're selecting a microphone that's going to be giving you the results that you have. If you switch from a table microphone, you've done all your calculations based on table microphones. You can't automatically switch to a ceiling microphone and expect the system to work in the same way. And of course, as I mentioned, equalization can be extremely helpful in helping notch out certain frequencies and overall making the system sound better for the participants in the space. Gino, I'll kick it back over to you.
Cool. Okay. Well, we're kind of nearing the end here and almost time for the question and answer portion. So, again, remember to enter your questions in the questions pane there, and we'll get to those in just a minute. Just kind of wanted to wrap up with a few useful tools that you can find on our website that might help you navigate some of these things. Of course, the PAGNAG calculator that I showed you earlier, there's a direct link to it, shure.com/Americas/PAGNAG, or just type PAG in the search bar on Shure.com, and it should be the first thing that comes up. If you're really interested in learning even more detail about maximizing gain before feedback in any sound system, we actually tackled this on a previous webinar in the past, and that webinar is archived. Again, you can find it at shure.com/training and click on the webinar archives, or there's also a direct link here to the blog post that would be hosting that particular webinar. So that goes a little even deeper into the whole gain before feedback topic, which is really obvious by now, pretty similar to what we've been discussing today. And then the last resource I wanted to point you to is a white paper that we have on our website about using the MXA 910 for voice lift. So if that's something that is of interest to you, that white paper is critical reading, I would say, and being able to implement that successfully, as well as just kind of some kind of reinforcing some of the principles of voice lift that we've talked about here today. If you'd like to get kind of a refresher on that, or kind of look at it in a little different format, that paper does include a lot of that good information. And again, you can find that under the support link for downloads. You can find that, as well as all of the other many educational publications we've put over the years. Those are all kind of archived there. So that's your resources. And now I think we are ready to start the question and answer portion. So let's see if we've got some questions. Oh, yes, we do. All right, great. Well, we'll get to as many of these as we can. If we don't get to your question, I would like to also point out that you can send your questions to support@shure.com, and someone from our applications engineering team will jump on that and be able to get an answer to you. But let's see what we can get through here today. Looks like, Troy, just for a heads up, we got a lot of questions about the 910 coming your way. Is there, I knew this one was going to come up, is there a suitable way to account for the MXA 910 in Shure's PAGNAG calculator?
Well, so as I mentioned, you can anticipate getting a minimum of about a 6 dB increase of gain when you're deploying the MXA 910 correctly. So if you use the ceiling microphone, and the calculation is the same, it's really the graphic that changes on the website tool. If you run those calculations on ceiling and you get green, the 910 is certainly going to improve your situation. If you run those calculations and you're in the yellow, that additional 6 dB of gain that you would get out of the 910 would certainly put you into the green. If you run those calculations and you're in the red, I wouldn't rely on the 910 providing that much improvement. So you need to go into the situation with an understanding that the 910 at a minimum is going to give you 6 dB increase of gain over a traditional microphone, and that'll allow you to make a better educated guess. What I would also say is that feel free to reach out to either your local market development person. We've got a number of people across the country who are in that role and or its support, and they're happy to take a look at your application and some of your calculations and determine if the MXA 910 is suitable for your purpose.
Similar question here too, which is the MXA 910. Is that Excel sheet available for download? And Troy, if I remember correctly, that was embedded in that white paper, right?
It is. It's in the white paper, and I'm not sure. I'm not 100% sure if the download is available or not. But again, that is something that I would rely on either support at Shure.com or your market development to help you with. Because if you haven't run that calculator before, it's always good to have an educated eye run those values for you.
Cool. Here's a question that might be a little involved, but let's see what we can do here. How do you deal with a system that was improperly designed and or not designed for voice lift to begin with? And I don't think you can say run away.
Yeah, no, well, runaway. I mean, if the system hasn't been designed as a voice lift system, you're going to need some reasonable surgery involved. So, obviously, at a minimum, you're going to need to create loudspeaker zones, right? So that means rewiring. And some of this is going to be logistics. Can you get back up in the ceiling to rewire the loudspeaker system? If you can, well then you've got a hope. But there's reasonable cost involved here. So again, we get to that cost to benefit ratio. If you do your calculations and you assume that you have a single zone 70-volt system, and now I'm going to try to create at least 4 zones out of that single zone system, and it's going to cost the client X number of dollars, and I can maybe only get 4 dB of gain out of the system. I'd want to make sure that my client knew what 4 dB of gain was, right? And that could be something as simple going in with a recording that plays back, the SPL at the one level that you can anticipate, and then what that 4 dB of gain is going to be. So if they're happy with 4 dB of gain, great, you've got your answer. If you run your calculations and you can get 10 dB of gain, well, they're probably going to be happy with 10 dB a gain, but without educating yourself or your client, it's kind of hard to say, yeah, go ahead. But of course, if you have access to the system and you have the ability to change loudspeaker zones, and that's probably the biggest difference, and certainly there'll be DSP programming that'll be part of that as well. You certainly can modify an existing system to provide voice lift if you want to go through the effort.
And your comment about asking or showing the client, demonstrating to them, like, what 4 dB sounds like or whatever it happens to be is really, it's a great comment because there's always a follow-up comment here from the person that asked the last question, which is that many customers seem to want to hear loud style reinforcement. I have many clients who say, we can hear it just fine, but when I am up front, I want to be able to hear myself from the audience speakers. Otherwise, I don't know that they can hear me. Right. So,
And that goes against the definition of voice lift, right? Now we're really talking rock and roll, and maybe you should have designed a performance center for them and not a conference room. So, um,
right.
managing client expectations are sometimes the hardest part of our jobs, right? But particularly with voice lift, I think it's very important to do so.
Yep. Is there a recommended maximum reverberation time for voice lift? In other words, if the room is large but has sufficient absorption to reduce RT60, can that work?
Yeah, I'm always loath to use the term RT60. RT60 is the time that it takes sound to decay 60 dB within a given space. Um, a cathedral, a performing arts center has an RT60. Conference rooms have such short decay times. I'm a little loath to call them RT60. Now, you have reflections within the space. They do have a decay time, which is generally very short, usually well under a second. So RT60, I don't know that it really applies in these spaces. Nobody's playing organ in a conference room, right? But you do have reflections, and it's usually the reflections within the space that are more detrimental than any sort of uh, um, uh, uh, reverberant sound within the room. It's the reflections that are usually the biggest issue for the microphone because of the path length difference between the direct sound and the reflected energy. You get that phasing kind of sound because of the direct reflected energy. But noise level, I would say, would be a greater concern of mine. We certainly want the rooms acoustically inert. And so any wall that is reflective that you can apply treatment to is certainly important. But then the noise level is another thing to look at, and trying to keep that noise level down to appreciable. And a lot of times you're walking into a space that you don't have control over in terms of what acoustical treatment you can put in there and or the noise level. You kind of have to live with it. All that much more important to kind of do your analysis and determine whether or not a voice lift is going to work in that space given the acoustical conditions and the background noise level in that space.
Great. Let's see here. Another question. Does the PAG-NAG calculator assume omnidirectional microphones? Yes, it does. Again, as you mentioned, Troy, if you're using the MXA 910, you can add about 60B to your PAG number, and that kind of helps you estimate the benefit of using something like that. Let's see. What else do we got here? How about using a single MXA 910 for two zones, aiming like lobes to one side and then a few lobes to the other side and using Dante to route them? How do you feel about that, Troy?
Well, since you can use Dante to route the lobes, if your calculations are proving out and it shows that you can do that given the distances, that that's fine because you are doing two different signal routings. As we get into larger spaces, it's going to be harder to do that because again, we don't want to aim a lobe into an active zone. So sometimes that mandates a second unit or a third unit, just in terms of the geometry of the space. And whatever obstructions we might have in there. We may have pendant mounted light fixtures or something like that, which may preclude you from aiming a lobe through that device. You certainly don't want to have any sort of obstruction. You want clear line of sight from the MXA 910 to the person who's talking. Otherwise, you're creating somewhat of a filter. So you theoretically, the answer is yes, you could do it. I'd have to look and see what you'd almost have to have perfect geometry in order to accomplish that. But sure, theoretically, you could do it with a single unit and route the different lobes to different loudspeaker zones.
Hmm. And then I guess similarly, if you are using multiple MXA 910s in a room with multiple speaker zones, um, and using the system for both voice lift and conferencing, is there any other maybe special considerations with multiple MXA 910s that we haven't addressed yet?
No, not really. It really comes down to your routing, right? So your mix matrix within your DSP is going to become key. And that's one of the reasons I recommend running those PAGNAG calculations for all of those. If we think, the simplest form that I showed here in the presentation were, what do we have? I had 4 microphones and 3 zones, which gives us 12 cross points. But again, if I had 8 microphones and 8 zones, I've got 64 cross points, right? So even with the use of a tool like the PAGNAG calculator on our site, I'm gonna have to run through that 64 times. It's going to take a little bit of time to do that, but I want to do that because I want to go into the commissioning of the system with a good understanding of just how much gain I can get at each of those cross points. So that's going to be key. So that would really be the main thing. Almost the number of microphones don't matter. It's really the number of channels, and then those number of channels are just going to complicate the routing, right? So that's going to create how many cross points you're going to have. Now, just because you have an MXA 910 and that has the capability of 8 lobes, you may not be using all 8 lobes. And in fact, in most cases, I've seen, it's always better sometimes for fewer lobes. You want to use as many lobes as possible out of the 910 in order to achieve the coverage that you need. You don't want to use all 8 lobes simply because they're there, right? It usually doesn't help anything in terms of intelligibility and certainly wouldn't help anything in terms of gain before feedback. So minimum number of lobes, make sure things are routed properly, and as some infamous people said previously, don't cross the streams.
Always good advice. Let's see. Is there a rule of thumb for ceiling speaker placement around a conference table in relationship to the microphone placement? An example, like should the speakers be over the table and inside of the microphones or outside of the table space? Because I think we had a drawing here that kind of showed maybe something like that.
Yeah, I would like to see that. Well, it's the D sub one, right? So the further away that you can move the loudspeaker away from the microphone and still provide coverage for those attending the meeting, wherever that they may be seated, is what you're looking for. So, assuming a traditional 8-inch loudspeaker has roughly about a 90-degree conical coverage, you may not want to be completely on access. As long as you're in the coverage of that loudspeaker, the ability to move that loudspeaker a little bit further away from the microphone, even if it's a half a foot, might give you a little bit of gain that might just tip it in your favor in terms of gain before feedback. So, as far away from the microphone as you can get, while still maintaining coverage of the people who are attending or participating in the space that you're designing.
All right. Looks like we have one more question here, unless somebody else jumps in. But I think this might be our last question. And just I'll give a clarifying point here before asking the question, which is for those of you who are not familiar with the MXA 910. It has a built-in auto mix feature. In other words, you can take in the an auto mix of all the active lobes instead of each lobe individually to feed your DSP. I believe that's what the asker is referring to here. But the question is actually, how does using IntelliMix affect how you apply DSP? Meaning, do I need AEC per channel per mic lobe? Or can I use IntelliMix? And I think this is really less about the voice lift and more about the acoustic echo cancellation. But Troy, what are your thoughts on auto mix versus per mic, per lobe echo cancellation?
Well, we our recommendation is always per channel AEC. In most cases, per channel AEC is going to give you better performance than the auto mix out. But that being said, there are a lot of successful systems out there that are deploying auto mix as part of their video or audio conferencing system. So it does work. Uh, my recommendation would be individual channel AEC wherever and whenever you can. But certainly, I have seen systems out there operating in a audio conference or video conference situation where you're taking the auto mix out of the 910. So it works. It wouldn't be what I would consider maybe first practice. I don't even want to use the word best practice, but my first practice would be to try to deploy AEC on each individual lobe, if you will. But if it was not done because of you're retrofitting an existing system and you only have a single channel of AEC left, or it's done as a budgetary concern, I've seen many systems work extremely well with the auto mix out of the 910.
Cool. Okay, we got one more question here. This will be our last one. Are there specialized DSPs for voice lift available? And then I'll add a qualifier onto that and say if there isn't, what are the features that you would recommend someone look for in a DSP that would make it good for voice lift?
Yeah, I think they're all pretty qualified to do voice lift. I don't, it really comes down to the size of the mix matrix that's required, right? So, as I mentioned, you have your number of microphone inputs, your number of zones. That's going to tell you how many cross points you're going to need as part of your mix matrix. So, you would be looking for a DSP that would get you at least that quantity or that size of mix matrix, if you will. Beyond that, you want to make sure that you've got equalization is key, and whatever else you're going to need. If it's part of a video conference or audio conference system where AEC is needed, you want to make sure that that system also can deploy AEC or has AEC as part of its feature set. So to me, in terms of voice lift alone, it really comes down to the mix matrix and ensuring that the mix matrix is of sufficient size given the number of microphones to the number of zones that you're going to be deploying within the voice lift.
Great. Okay, well, that's all the questions we have time for today. Again, if we didn't get to your question, please make sure to send it to support@shure.com, and we will get to that as quickly as we can. Don't forget, the webinar will be available in our archive in about a week at shure.com/training. And thanks, Troy, for lending us your expertise today. Thanks to everyone for listening in, and we will see you next time. Thanks.